Welcome to Competency 18 quiz. In this video, we will review planning and instruction. Number 1, Isabel is renting an electric scooter. The rental requires a down payment of $8 plus $5 for each hour the scooter is rented. If C is the total cost and T the total charge rather, and T is the number of hours that Isabel rented the scooter. Which of the following equations represents the relationship between the amount of time she rented the scooter and the total cost, which would be total charge? Either way. Okay. Well, the reason they ask a question like this is because if you can't answer it, then that means you don't know how to teach the children how to pick through these questions. And how do you pick through it? Well, down payment would be the initial value. That would be what we would call the B value. And we would have an equation representing y equals, it's mx. mx plus b. And y in this situation would be represented with the C because those are both total cost, and you put your equal. Now, we know what the B value is. That would be 8. And we know we're going to be adding because it says plus. Well, plus what? $5 for each hour. Okay. I always teach my students, you look for the rate. And how do you look for the rate? The rate would be the M. Okay, you look for your rate, and it's always in front of a situation that would be like the unit rate, uh, meaning that it would say for each, per each, for one, each of them cost, any kind of verbiage like that. Okay, and in this situation, what do we have? We have $5 and this for each hour. Well, what is that? Well, we said, okay, it's T. Well, they're telling us to write T. So right here, we're going to write T. So that's going to be represented by a T. Okay, so which one is that? Well, that's going to be option B. Now, obviously, let's look at C. They have the rate and the initial value confused. And on D, same thing. And then they have this condition here for our time where they subtract $1 out. Well, nowhere in our problem was that verbalized. So it doesn't exist in our problem. So obviously, everything about D is incorrect. Now let's look at A. Well, A is not valid because our rate, they're telling us our rate is 1/5. And that would be if you were confused. An hour, 1/5 somehow that you confused hour per 5, that an hour per $5 somehow, I don't know. But if you pop that in your calculator, of course, that's 20 cents. Well, nowhere was 20 cents or rate of 0.20 ever mentioned. So that's not going to work, obviously. Okay, let's look at number 2. A mathematics teacher requires students in a 6th grade class to keep a mathematics diary. Each day, the students are asked to record when and how they use mathematics in their daily lives. Okay, so they have to think about, I went to the store today and I had to decide if I had enough money. Okay, it's something simple like that. Or, uh, I was going somewhere with friends and I had to make sure that I brought enough snacks or something like that, some simple situation. Okay. Every day, the students are asked to record when and how they use mathematics in their daily lives. Okay. At the end of each week, the students each write a short report on their use of mathematics, and the teacher reviews their diaries. Which of the following is the which of the following is a teacher demonstrating with this activity? Okay, so what is the purpose of the teacher for doing this? Well, let's look at what they want from A, B, C, and D. And I have a good idea that it's to make the students relate what they're doing in class to what they're doing in the outside world. Students never relate that. Okay. They just want to go on with their day. They really don't care about math class, right? Okay, so let's see what A says. An understanding of a variety of questioning strategies to encourage mathematical discourse and to help students analyze, evaluate, and communicate their mathematical thinking. Okay, communicating mathematical thinking. I like that part right there. I think that's the main phrase. And because of that phrase alone, I like A. I'm not going to discard it. Okay. Now let's look at B. An understanding of the use of inductive reasoning to make conjectures and deductive models to evaluate the validity of oh wow, no. There no way. And we're talking 6th grade. 6th grade kids, no, this is a little bit much. I disagree, and I don't think that's the purpose of the teacher. I think it's more along with what A is. Just trying to get them to communicate and see that they're using it and to analyze their day. And when they're done with a journal like this, they're going to stop saying, "Well, I never use math. I don't need this." Okay? All right. They could have been out and about with dad, and dad went somewhere like Lowe's or Home Depot and was trying to figure out how much of a runner of carpet, like a stair runner or something he needed. Okay. They could have been along for that and wrote about that. I mean, you never know. I mean, I would have. My dad did that kind of thing all the time, but it all depends on the child's perspective. But B, for a 6th grader, no. And notice I used the fact that they said 6th grade. If this had been another level of student, then we would be talking differently. Okay. All right. Now, C, an understanding of the purpose, characteristics, and use. Oh, summative assessment. There was no summative assessment here. So that alone gets rid of C. We are not talking about that. We're simply saying, what is the purpose of this educator for doing this? Okay. I marked through that instead of under it. It's okay. Now let's look at D. An understanding of how uh, technological tools and manipulatives can be used appropriately to assign students to develop. Okay, nowhere are we talking about manipulatives or comprehending, applying mathematical concepts. They're not talking about how they apply it. They're just recalling, keeping a journal, and talking about it in the keep a daily journal. Every student was asked how they used mathematics. They're just looking at their day, analyzing what they did, and coming up where they used mathematics. And the teacher isn't using it as an assessment. Okay. So D isn't going to work for me either. The only thing that actually works is A, and that is because of this last line right here, or last little phrase. That's my favorite part of it. They just don't know how to do that. They they can talk about their day, and some of them is 6th grade. They're eager to please still, and they're going to tell you a lot sometimes. Sometimes they don't want to do it. But to get them to think about their day and what happened during that day and how did they really use any math? Sometimes they dismiss when they do. It's just to get them to think about it and then write a little something. Okay. And I like it. Okay, let's go to number 3. Number 3, let f of x equal x minus 100, x minus 125, x minus 150, x minus 175. A student wants to use a graphing calculator to find the points in the XY plane where the graph of f crosses the x-axis. Which of the following bounds on x can be used in a viewing window so the calculator displays all the points where the graph of f crosses the x-axis? Okay, basically what they're saying is, hey, where will you see all of these points to be able to answer the question? Okay, well, we see our maximum and minimum. Okay, each of these little expressions in our parentheses can just be pulled out to say x equals 100 and x equals 125 and x equals 150 and x equals 175. Okay, now we know that the minimum is going to be 100 and our max is 175. So if we have, that looks very strange to me. Okay, so if we go a little bit below 100, a little less than 100, and a little bit above 175 on the x-axis, then we know we're going to see all of our graph, okay? All right, so let's think about this. We have the x-axis, and what is really happening? This is going to look like this. Now, I just know it's going to look like that because of the type of function that it is. Our calculator is not graphing. Now, if you want to put it in your calculator, so let's go ahead and do that. Let's clear that out. We can. And then we kind of can look at, we can go up and down and look at what we've got, okay? If that makes you feel better. It did me. I kind of had to do it. Okay. All right. And then there, and then x minus 125, and then close, and then x minus 150, close and open. And then I had x minus, okay, and that's 175, and I close. Now you may be thinking, well, what good would this do us? Well, it doesn't do us a whole lot as far as the visual, okay? But it does do this for us. Let's look at our ABCD options. And okay, I'm going to go ahead and delete these out. Now, one thing that we can see here is each of our x values. I know that here I'm going to have x is 100, and then on the other end, I would have 175. But look at each of them. We have positive values. A is saying our window needs to be from a negative value only up to 75, which would be, let's just say 75's here, okay? Well, and then it would go to the other end, very far negative. I don't like that. That's not even going to be the window we need. So now I've drawn it out. And one thing we can do is if we put negative I mean, where's our y going to be? That's just going to be kind of crazy. I don't think we're going to be able to get that in our window at all. I mean, it's not going to show anything. I'm look at the 75. No, A's out. So let's look at B. Negative 200 to negative 75. Again, everything's negative. It's all to the left. We will see nothing. Okay, and if you put negative 200 in, look at what kind of a, I mean, we're not even going to get a good y value. It's not even going to be close. We're even going to have a hard time seeing the upper tail of our function. So it'll be like a blank screen. So that's not going to help us. Okay. And then we could even try negative 100, and let's see what kind of y we get. Well, that's a little better, but probably off screen. So that's not helping us either. Okay. Now, but if we look at D, it just makes sense. It's going to have 75 right here. And then over on the other side here, somewhere over here, we'll have 200 because we had here, this was 100. And then this point here was 175. And naturally, we're going to hit our other two dots in between. So our window will suffice, okay? Our window will be good. So if we put, just out of curiosity, what I did is I put 75 in, and yeah, it got a pretty big number, but that's telling me that my calculator is probably going to be able to show me the tail of my function, and then I put in 100. Of course, that's going to equal 0. And then if you put in 200, look at what it does. This tells me that from 75 to 200, we're going to have a nice square even window. Okay, that's what it told me. And that's why I selected D, because it would be the best window to show me my entire function and my values of X. Okay. All right, that was a little long-winded to maybe uh get to Captain Obvious for you, but it maybe gave some other thought on what you're looking for. Okay, let's look at number 4. All right. A middle school teacher provided each student with a detailed step by step instruction for solving a quadratic equation, which includes written explanations of each step and a graph of the function. Okay, I can visualize that. After analyzing a warm up over quadratic equations, the teacher noticed that over 50% of the students earned below 70% on their exit ticket. Which of the following changes would be best to the activity to include more types of learners? Ooh, okay. Well, let's look at A. After the activity, students need to complete more practice problems with word problems. No. Word problems, that implies more reading, and they already have that with their written explanations. So that's just has students doing more things that they don't understand on their own. It's just adding more fuel to the fire, per se. So that's not a good one. Let's look at B. The students need to watch a video clip illustrating how to solve the quadratic equation before the activity. I don't know how helpful that would be. It is a visual, but there is also a graph with the function. So, unless it had more audio, which it doesn't say, it just says video clip. I don't think that's the best choice. I'll put a line on under it, but I'm not seeing what I think I need. So let's look at C. Use algebra tiles to solve the equation and verbally explain their reasoning. Then help the students connect their reasoning to the detailed step by step illustration. That I agree with. And sometimes it seems kind of silly, and the students want to play around, yes. Like they like the tiles, but sometimes just having them move step by step and doing it, and it won't take much to do, even though they think it's a little childish. Some students don't like doing it. They don't like getting out the algebra tiles. I thought they would, but it's interesting. However, if you go around and check them and see that they're doing it, and then just make those simple little connections, you'd be amazed the difference the next time around, and you'll capture more students. So I like C better than B. So I'm going to mark B out. Okay, let's look at D. Have the students use a graphic calculator to check all their conclusions. That's just checking how wrong they are. All that's going to do is I'm still wrong. I've just proved I'm still wrong. I don't like that one. Okay, I think we verified. C is what we need. Okay, this is the last question for this video. And again, I wanted to thank everyone for subscribing, liking, and sharing our channel. It's greatly appreciated. And I want to take this opportunity to wish everyone happy testing.